Hi, this is Jose Luis here, and welcome to another video on this series, Introduction to Parametric Modeling. In this exercise, what I would like to do is I would like to show you how to use meshes to display information using their property of vertex colors. So the exercise that we're going to do is we're going to do a very simple estimation of a solder analysis exercise where I'm going to have a free-form NURBS surface that I will turn into a mesh. And I'm going to have this point that is going to represent, for example, a sun that would be hitting the surface with a set of rays. And then what I would like to do is I would like to use this exercise to convert the surface into a mesh and then to color the mesh using different gradients. So for example, this in this case is gray, in this case is going to be red, or in this case is going to be a collection of different colors to manifest which areas the rays are hitting more frontally and which areas the ray of the sun are hitting more tangentially, if you will. So, and it's going to look something like this. So I'm going to turn on the mesh and then I'm going to hide this thing here, and you're going to see that the mesh is now colored with a code representing how strongly the sun is hitting its surface frontally. So you can see when it goes here, all this area is very frontal, whereas this area here is not. And then we're going to finish the exercise by making an animation of this, creating a video where we can see how, as the point moves, the change of this color gradient happens. This video could be a really nice video to showcase like a daylight animation or some kind of other stuff, if you will. Okay? So shall we get started? It's going to be a super fun exercise and very easy to do as well. This exercise is going to be extremely similar to one that we did a few exercises ago in this series, which was that we had a surface and then we populated the surface with a bunch of openings or circles, each one of the circles having a radius that was proportional to the angle at which a virtual sun was hitting that surface. So we're going to do a very similar exercise. We're going to start off with a free-form surface, which we're going to imagine is some kind of facade, for example. But because it's going to be a NURBS surface, the first thing that we're going to do is that we're actually going to turn this surface into a mesh. And we're going to do it in a very simple way, which is going to be finding UV points on top of that surface and then creating a mesh out of those UV points, which is going to be a super simple process. And then once we have that mesh, what I would like to do is I would like to set up some kind of virtual sun. So it's going to be a point. And then I will do very similar to what I did in the other exercise, which is I will calculate vectors hitting each one of the vertices. I will calculate the angle between those vectors and the normal vectors to the mesh to see how strongly, how frontally the sun is hitting that mesh. And then I will use that information somehow, whatever values I obtain, to design an RGB color that we will apply to the mesh. We haven't seen colors yet on this series. We will see those farther down when we talk about images, but I will explain it real quick and then we can talk about those a bit more when we start talking about images. So this is going to be the overall structure. It's going to be super easy and super similar to the previous exercise. Let's just do it. For this exercise, we're actually going to be using the exact same surface that we used on that other exercise, which is basically a NURBS surface that I have in Rhino, which is coming from the design or from the architect or from whoever decided whoever decided the form of this building. Okay, so I'm going to take that surface inside of Grasshopper. So that's going to be one thing. I have it there, and then I'm also going to bring in this point, which is going to be the point that represents the center of the sun and where all those rays are coming from. Now, once I have the surface, the first thing that I need to do is I need to convert that NURBS surface into a mesh. The process that I explain in the sketch is basically taking a grid of UV points and creating a mesh out of that. We could do that manually, although doing that in straight Grasshopper manually is a little tedious. So it's actually, if you go to the mesh tab, to the mesh tab and you go to the utility categories, you can see that there is one component here that is called mesh from surface. And the way this works is that it takes any surface geometry, and then it takes how many divisions do we want in the U and the V directions, and then a couple other parameters like overhangs, equalize, and blah, 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 which we're not really interested in right now. And what that gives me is a mesh that has whatever divisions in one direction and however many divisions in the other direction. So something like this. And I'm going to hide this, and I'm going to also hide this, and I have this. I'm going to turn this off. And if you are not seeing these subdivisions on the mesh, it's because you need to remember to go to display and to turn on preview mesh edges, which I think is very useful when we're working with meshes in Grasshopper, so that you can see these subdivisions, right? Okay, so the next thing is just going to be as simple as calculating the angle of all the rays that are hitting this mesh with the normals to the mesh. So for that, we need to do first is deconstruct the mesh into its elements. So if I do that, you see that I get a cloud of points, so all the vertices, but I also get here all the normals to that mesh. And I'm going to start putting in a panel here so that I can start taking a look at what is coming out of my components. Having panels also always to check things out is extremely useful for development. So we're going to do that, and then the next thing I'm going to do is I have all the vertices here, so I can now calculate the vectors that go from the sun to each one of these vertices. So that's going to be a vector between 2 points, which is the first one going to be the sun, the virtual sun, and the second one, all the vertices. And now, just for the sake of visual reference, I'm going to display the vector. I'm going to display all these vectors anchored in the sun. And as I do that, you can see that I have all these vectors here. The other thing that I may want to visualize are going to be, I'm going to hide this. The other thing that I may want to visualize is the normals to the vertices, so that I can do by visualizing the normals, which are here, and the vertices that are here. So you can see that I have all these normals here. Right, so that looks great to me. And then what we're going to do now is we're going to just calculate the angle between all these vectors and all their normals. So that's going to be super easy to do. What I'm going to do is I'm just going to calculate the angle between two vectors that I can find here, or that I can find under vector and vector operations. You can compute the angle between two vectors, and the vectors are going to be, first are going to be the sun vectors, so that's going to be 1, and the other ones are going to be the normal vectors. The angle is going to be this list, which is given in radians. Remember? Sorry, not radians. Radians, yes. And once I have that, we know that radians go from, what do they go from? They go from 0 to 2 pi, correct? And that's when we go from 0 to 360. However, the only possible angle between these two vectors can only be can be an angle of 0 if both vectors are like this, or it can be an angle of 180 if both vectors are exactly opposite. It cannot be any more because we don't have the other full range, because we don't know if the vector is to the left or to the right. That doesn't matter. So therefore, the range of the angles values are going to go from 0 to pi. And we have talked previously in this series how it's very typical and very useful to just normalize things and make values work from 0 to 1. It's just much easier to analyze things that way. If we do it that way, then we know that 1 is going to be when the angle is absolutely opposite to the sun, and 0 is going to be when the perpendicularity is in the same direction as the sun. So what I'm going to do is I'm going to take all these numbers and I'm going to remap them. This is exactly what we did in the previous exercise with the Solver analysis. I'm going to remap all these numbers. So the values are going to be here, and then the source domain is going to be a domain that is going to go from 0 to 0 to pi, and I'm going to write it 0 to pi, and I'm going to write it here in a panel because it's something that I will never want to change, so I don't need to waste sliders or anything, and it's also just much faster to write. And then the target is going to be from 0 to 1, and that's also the other thing that I want. So now you can see that these were my previous angles, and then my remapped angles are going to be something like this. Are going to be these values here, and we can see that there's no value really that is close to 0. I can't really see many. No. So they're always somewhere in the middle. Okay. All right. So now I have a list of numbers. I'm going to turn off all these vectors, and I'm going to turn off this, and I'm just going to keep the mesh, the clean mesh. Now I have a range of numbers that go from 0 to 1, which represent how strongly, how frontally the sun is hitting each one of the points on this mesh. This is what these numbers are representing. 0 being that so 1 being that is very frontal, and 0 also being that it's not. So like this, okay? All right, so now what I would like to do is I would like to use those numbers. I would like to use those numbers to represent here on the mesh with colors how strongly the sun is hitting the mesh. So the idea is that for the first thing that I would need to do is, well, the way this will work eventually is by going to meshes, going to primitives, and creating a new mesh, so constructing a new mesh that is going to take the same vertices as the original mesh, is going to take the same faces, and you can see that I already have a mesh on top of here, but I need to give it optional vertex colors. So I need to give it colors that represent this incidence of the sun. And once I give it colors, they will show up here. The problem is we have not seen colors yet. So how are we going to do that? So we haven't talked about colors yet on this series, and I would actually like to wait until we talk about images, which I think is going to be later in this series. So perhaps what we could do is I could just give you like a really quick crash course and just saying that colors are typically represented with 3 numbers, basically. So for example, if I go to the inputs tab and I drop here a color picker, and I set it to RGB space, what you can see is that when I move these 3 sliders here, I can basically move through a set of different colors, right? And each one of them is driven by the value of these 3 things called RGB. RGB stands for the red channel, the green channel, and the blue channel. And it's these 3 colors because optically, light, these are the 3 primary colors that when combined, they can generate any other color in the spectrum. This only works for light. When it comes to print, see, we use a different set of primary colors. It's a different story. And then you can see that if I drop a panel, the output of this is these 3 numbers, the RGB values that are making up any particular color. And you can see that it's also a very, very common standard that each one of these 3 values has a range that goes from 0 to 255, aka they have 256 possible values. Remember, we start counting by 0 always. Now, why these 3 colors? Why 256? Blah, 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 whatever. That's a whole different topic, and we can talk about that more extensively in some other lecture. But this is basically how we represent color. And also, if we just want to represent grayscale, then if we just set the 3 values to the same values, so for example 137, we will be somewhere like a dark gray. And if the three of them are zero, then we're black. And if the three of them are very high, we are in a very clear shade of gray. Okay? So creating color basically means creating three numbers that correspond to the RGB values, and then just creating those three numbers somehow. So I can, for example, if I just wanted to make the mesh, I just wanted to make it pink like this, I could see that I could set this color, which is what corresponds to like a really bright pink or magenta or whatever that is, and use that as the color that I used to color the full mesh. And you can see that the mesh is now pink. This is not a shading effect. This is due to the fact that I have assigned the same color to all the vertices in the mesh. But what I want to do now is I want to assign different colors to each vertex on the mesh. And I want those colors to be proportional to how strongly the sun is hitting that mesh. So we know how strongly that is because we have values from 0 to 1 that tell me how strong they are. So we can generate perhaps RGB colors with that. The way we generate colors in Grasshopper is either using the color picker, or if we want to do this programmatically with components, there is a whole tab here under display and color, and you can see that I can create colors in all different color spaces. We're not going to get into CMYK, HSV, whatever. We're not going to get into that. The most common one, especially for computer graphics, is RGB. So I'm going to drop this component here, and this component is going to create a color based on RGB and alpha if I so wanted to, which means transparency if I also wanted to. So what I could do is I could just basically plug in here the values that I have calculated and then use this as the color. However, the problem with that is that it's going to give me colors that are 1, 1, 1, 1, 1 in the best case, and sometimes it's going to be 1, 0, 0. It's going to be 0, 0, 0 because the numbers here go from 0 to 1. And here they get rounded because this component expects numbers going from 0 to 255. So what I would need to do is I would need to take all these numbers that are now in the range of 0 to 1, and I would need to remap them so that instead of 0 to 1, now what they do is they go from 0 to 255. Okay, so now I have remapped all those values again, and now I have a new family of values going from 0 to 255. Or I could just change this one here as well, if I were going to keep this, which I'm not going to. So that's why I just remapped all those numbers again. Remapping numbers is a super simple operation, so it doesn't really take computational resources. So now I can plug this in here, and I can plug this in here, and in here, and you can see that now the mesh has this shade of lighter gray here and darker gray here, which is not a shading effect in Rhino. So look me up. If I move this, you can see how this looks like the sun is actually illuminating the surface in a way, and this looks like the shadow, right? This is because we are coloring those areas that have a more frontal orientation. We're coloring them with a higher level here. We're using the same value for the three channels RGB, therefore giving us a grayscale. However, I could also just choose to use one of the channels. So I could just choose to use red, for example, as the color. I could choose to instead, for example, I could choose to use blue, and then blue is going to be the color that I use for the shading, or I could choose to use green. Okay, so that could be another way to go. And also, I want to highlight that here, because RGB is so popular, there's a special component which is called RGB from floating point, which expects colors, instead of going from 0 to 255 for each channel, expects colors going from 0 to 1. So with this component, I could have saved myself the hassle of remapping all those values from 0 to 255 and just stick to the values that go from 0 to 1. Because again, working in the range of 0 to 1 is a super common thing to do, and it makes a lot of things much easier. And then always changing to a different range is super easy because the only thing you need to do is to multiply those numbers. So this would be how I would play out using, for example, a shade of gray to specify the color. This could also work just for like a super rough rendering technique, right? So that could also work. And if I now bake this geometry, this mesh, you can see that I get a resulting mesh that already has that grayscale embedded on it. And again, this is not a shading effect from Rhino. This is actually the color of the mesh. And this is how it's going to look. This is how it's going to look forever. So let me actually, to make sure that this is clear, let me actually do a red version of it. So, and then let me bake that and then put it right here. So that now when we do rendered, we can see that this stays red because it's a mesh that has its own shading. Okay? But we're not going to stop there. We can do a little nicer because turns out that Grasshopper has a really nifty component which is called color gradients. And I believe it's somewhere here. Yes. So what this does is that this component gives us a way of mapping a range of numbers to a range of colors. So for example, what does that mean? What it means is, if I look at this component here, this component right now is telling me that it's asking me what is going to be the lower limit of the gradient range and what is going to be the upper limit. And these are numbers. So right now they are 0 to 1. So I'm going to keep that because my values also are within that range, within the range from 0 to 1. And then what the component will do is that for any parameter, so for any value that I give it, within that range, it will generate a color based on this nice UI gradient here. It will give me the whatever color that array, whatever color a value that falls within that scope from 0 to 1, whatever it will fall within that gradient. So what that means is that I'm going to give it this, and you're going to see that I get a bunch of colors that are mostly red with a tiny bit of color in the R, in the G and the B channels. And if I use that for the gradient, you can see that it looks very similar to the red one I had, but it's slightly different. It's more pinkish here, if you will. Or, for example, what I can go to presets and say, I want to do this one. And this one is actually going to be opposite to what I want. I want darker here and I want gray here. So, but you see how I can actually just modify where the height points of those colors are, which is super interesting. Or for example, I can choose brownish. This is not a great brown actually. But for example, yes, I can choose to have this brown, or one of the most popular ones are either this one, which represents values. So this and this, or this one is also really popular. So you can see how here, for example, we would have values, right? Something like this. And then if I actually flip them, something like this, we would get, for example, some values like this. And actually I'm going to move this around a little bit. No, this is too much. Here and here and here and here. Can you see? So now this is telling me very strongly which areas are facing very frontally the sun and which areas are not. And if I move my point, you can see that those colors are going to change, right? Those colors are going to change on the mesh. And actually, what we could, wait, sorry. And I'm going to, let me just bake this just for the sake of having, yes. And then I'm going to bake this and it's going to go here. And you can see that I now do Arctic, for example. And I still have my mesh with my colors very cleanly because it's part of the data inside of the mesh. This is a really, really common technique, okay? And you know what's going to be cool? I think we should make an animation out of this, right? So I'm going to follow the technique that I used on my previous video where I was talking about making animations with Grasshopper. And I'm just going to animate this point moving along this line here and then taking screenshots here. That's going to be a lot of fun, actually. Let me do that offline and I will show you the result. Okay, so what I've done is that instead of having one point that I'm going to move, what I did was I created one line and then I created a point that I can situate along that line between 0 and 1, which is affecting the solar radiation as well. And that's the point that I'm going to be using for calculations. And also, if you look closely, I also really, really cranked up the definition of the mesh. So now each facet is way smaller, just so that I could get a more smooth definition. So that it looked something, so that instead of having like these really big meshes, so that I had that nice definition and the colors blended real well. And then what I did was I just animated this slider and created all the frames for the animation. The frames look something like this because I turn off, by the way, sorry, I also turn off preview mesh edges for this animation. I turned it off so that I didn't see like the nasty red lines. And then the video ended up looking something like this. How nice is that, huh? The super, super smooth movement of the point, and then how the colors of the analysis are blending together, right? And the darker, the warmer areas is where the sun is hitting more frontally, and the cooler areas is where it's more at an angle. So, all right, I think with this, I am very happy with where we are. So we are going to wrap the exercise here. Now, remember, this that I just did it's not exact, it's not a good canonical technical solar analysis. It's just a super, super simple estimation of the angle of a particular point to a particular other point on the surface. Real solar analysis is way more complex than this, but the idea of using meshes and using mesh color to represent and to communicate this analysis is actually a very, very common technique. So the way this can be done manually in Grasshopper is the way we have seen here on this exercise. I hope this was fun and this was exciting for you. And I hope you learned something with this. And if you think you did, maybe consider liking this video, subscribing to the channel, sending some love, leaving a comment here, turning on notifications, whatever your jam is. Okay? Thank you very much and see you on the next videos on this series.